Now let's define an electric dipole. So say suppose this is a charge that is plus q and it is separated by a distance. Let's take this to be twice a. This is minus q. So electric dipole is defined as a pair of equal and opposite point charges. These are point charges. Point charges. So what is electric dipole? If this is a question, then your answer should be it is a pair of equal and opposite point charges and opposite point charges, namely say q1 and minus q, that is q and minus q, and it is separated by a distance of twice a. So this is how we define electric dipole. And what is the direction of the electric dipole? If another question comes, what is the direction? So you can explain the direction in such a way that the line connecting the two charges define a direction in space, and by convention, that is the line connecting the two space. This is the line connecting the two space. So this is a direction, and the direction follows that if you take minus q, say suppose you take minus q and you go towards q, that is plus q. So the direction from minus q to q is said to be the direction of the dipole. So the line joining q and minus q in space, and the direction follows as from minus q to q. So you will have a dipole's direction in this manner. This is your dipole's direction. Line joining q to minus q and direction, that is from minus q to q, is a direction dipole. And if you look at the center, that is the center of the distance between them, then this is known as the center of the dipole. Center of dipole. So these are all the things that you need to know about dipole. Now there is an interesting fact that you can consider. Say suppose this is a dipole, this is q and this is minus q, and you are taking, so if we consider the total charge of an electric dipole, total charge of an electric dipole, this will be 0. Now, if the total charge of an electric dipole is 0, it does not necessarily mean that the electric field will also be 0. Electric field. So the question comes, what will be the electric field? Now, as we know, electric field is due to, we know that it goes from the positive to the negative, as we have discussed earlier in our previous slides. So this is the electric field. Sometimes some electric fields may go over here, it may take a huge curves, others go over here. So we have an electric field of this nature. So even though the total electric charge is 0 of this system, but there is a possibility that there may be electric field. So what will be the electric field because of a dipole? So let's have a discussion on that. So now let's have a discussion what happens with the electric field See, this is Q and this is minus Q. This distance is twice A. So this is the center of dipole, center, and this distance is twice A. So what happens when there is a point P on the axis of the dipole, see, this is the line, this is the direction of the dipole, so this is the axis of the dipole that is joining the point Q and minus Q. So what is the electric field at that particular point? So for now we have assumed that let P be a distance r. So P is at a distance r from the center. So this is the distance r from the center of the dipole. This is the center of the dipole. Now what is this distance? This distance is A. Now if you consider the individual electric field, or because of point Q and because of point that is minus Q and Q, then maybe we can find the total electric field. So let's have a look. Now for point minus Q, what we have is electric field is actually given by minus Q divided by 4 pi epsilon naught into the distance between these two. So if this is a distance r and this is a distance A, so the distance between Q and P is actually A. That is r minus A. So this is A and this is whole is r. So this distance is whole r minus A. This is r minus A. So this is r minus A whole square into direction vector of P. That is in the direction of the point P. So this is what it means. Now similarly, if you are taking the electric field because of say Q or plus Q, then you have plus Q into 4 pi epsilon naught, and the distance is, if this is twice A, then this is A. So this distance from here, this is R and this is A. This becomes R plus A whole square, and this is P cap. So now the total, if you look at the total, you have E total is equal to E of minus Q plus E of plus Q. Now this is given by Q. If I take Q common from here, by 4 pi epsilon naught, what I have is, if this is my minus and this is my plus, so now this is 1 by R plus A whole square minus of 1 by R minus A whole square. So this is what I have. Now say suppose if the point was over here, then we just have to change its direction. This is 1 by R minus A minus 1 by R plus A. So this is the electric field that we experience. Now whether this is due to negative charge, and this is due to positive charge. Now it does not matter whether you take P over here or P over here, your negative and positive sign, because if you rearrange your values, it will automatically be adjusted. Now I want to emphasize on a point that in your book the P is taken over here. So the P is taken over here, and the example is being proved by taking P on the left hand side of the positive Q. So now I want the students to understand the concept rather than memorizing the way of doing the sum. So just understand the concept, how we can take out the electric field. So the total electric field is given by this particular formula.